Good afternoon, everyone. Good morning or good evening, depending where you are. I am Pavlos Protopapas. I am the Scientific Program Director for the Institute for Applied Computational Science. Today is an honor to introduce the first speaker, and Karim kind of represents both worlds. He's both in academia and industry, and his talk today will be more in his engagement in his startup. Let me introduce Karim. Karim is one of my oldest collaborators. He finished his PhD in 2010 in computer science for Católica University in Chile. Then from 2010 to 2012, he was at Harvard as a postdoc. He specialized in machine learning for astronomical problems. And then he became a co-founder of the NotCo company, who he's going to introduce today. He's still actually active researcher in machine learning, involved with some of other labs here at Harvard in astroinformatics and astrostatistics. So it's a great pleasure to have Karim, one of my older and good friends, giving the first talk of this semester. Thank you, Karim. Go ahead.
Thank you, Pablos. Thanks. So I want to start with this shameful slide, to be honest. We're defining what are the CAFOs, which means like a concentrated animal feeding operation. To me, it's one of the shameful things of humanity, because it has like a health, environmental, and ethical concerns, right? So here we have some scary numbers that are directly related with the food industry today. For example, in general, producing animals for food consumes exponentially higher numbers of water. Today, 70% of world's available fresh water is spent in the food industry, in the animal food industry. Regarding the deforestation, 80% of the global deforestation comes from the exploitation of cows. Related to the greenhouse gas emissions, is the same story. Like we have a exponentially bigger amount of greenhouse gas emissions, and 30% of the total greenhouse gas emissions in the world come from the animals exploited for food. We can also mention stuff like the use of antibiotics to keep them in these places without free of bacteria. They need to be constantly under big amounts of antibiotics. In other words, increasing the livelihoods of creating bacteria that resist all these antibiotics. And on top of that, to keep these the cows in a constant lactancy-like state, we need to give them like hormones, and then later they pass to humans through the milk. I think you are already familiar with this picture, but it is very likely that the next pandemic comes from these CAFOs. Actually, we already had one case with the swine pandemic, and this is because basically we have thousands of animals together, increasing the amount of trespassing viruses from one individual to another, and on top of that, from one country to another, since we are sending animals back and forth, increasing the livelihoods of coming up with some really bad mutations and passing genetic materials that can end up in a very dangerous virus. It's just a matter of time that we get this kind of pandemic. Today, we are just playing with the probabilities. So we believe at NotCo that we must completely change the food system. And our proposal here is like we combine AI and deep science that helps us to take out the animal from the food equation. So we want to impact the world from two main aspects. The first one is to offering like mouth-wateringly delicious plant-based food products that appeal to the mass market. And also we want to help other companies to change the way they make foods by using NotCo's technology and science. So what are the main challenges to do this? The first one is that people love to eat animal-based foods. And in general, the plant-based products are usually known for being non-tasty. On top of that, the food producers are created to satisfy an animal-centered market. Same thing with the ingredient providers, right? They are born to supply an animal-centered industry. And in addition, professionals are trained for a food industry that is around the animal-based system as well. So we have all these problems to overcome. So what is our story? We are three founders. Pablo Zamora is a PhD in biotechnology, and he did a postdoc in UC Davis on plant genomics. He is one of the founders, and today is a scientific advisor of the company. We have Matías, our CEO. He's an economist guy. He did several executive programs at Harvard, Stanford, Berkeley. So he's the main founder of the company and in charge of all the business of our startup, right? And I am a computer scientist. As Pablo said, I did a PhD in computer science and also a postdoc under Pablo's advice here at IACS Harvard. So we are a 5-year-old Chilean originary company with the support of all the investors that you can see in the right side. So far, we raised 120 million divided across 3 series of fundraising. And today, we have 4 categories of products in 4 countries. In 2020, we could sell 8,400 tons of plant-based products. It was 5x the amount we sold in 2019. And we are more than 200 full-time employees across the different countries. These are images of our current products. Most of them are available in Chile. In the US, we only have the 2 versions of the NotMilk. And hopefully soon we're going to have all the other products. And depending on the country, also we have different versions of the products. For example, in Argentina, we have different flavors for the NotIceCream. But I'm here mostly to speak about the technology. So our technology, our AI technology is called Giuseppe. And I want to start first showing how NotCo envisions the product creation pipeline, right? We have different stages. The first one is like the idea screening, where we brainstorm potential future products, trying to fit the market, trying to see what products are going to have a better impact from the sustainability perspective. And also what are the likelihoods of coming up with a product that is really close to the animal version. So after deciding on the next product, everything starts with the creation of a prototype. So in the initial development, the AI team together with the R&D start working in having the first prototype, such that later we try to solve the scalability issues. Like it's one thing is to have a product that looks very nice in the kitchen, but then being able to produce that product at scale is another story. You need to solve a bunch of problems. We're gonna go over some of them later. These 2 main centers stage are addressed with technology and science. So later we launch the product and then we have to take care of the post-launch. And so every time we need to be improving the products, coming out with new flavors, listening the consumers and get better and better. And this is a non-stop iteration, right? So why we call Giuseppe to our technology? Giuseppe is an artist that was painting faces of people just using vegetables. So it's kind of related with what we want to do. I know that some of the pictures are kind of creepy, but anyway, I like them. So this is the Vertomnos is the main picture we use to represent Giuseppe in this history of the company. And so this is why we named Giuseppe to our technology, right? So like doing a double click in the product development parts of the pipeline, usually we envision the product creation with these main steps. When we create the prototype, we work it like in the culinary aspects of the products, like making sure it has a nice texture, it looks similar to the animal version and has a nice taste, of course. And the modules that interact with the humans there are called Viaggio. This is after Giuseppe's father. And in the middle, when we already have the prototype, we're going into the functionality and scalability parsing, where we need to solve problems related to consistency maybe, or texture and other stuff that need to prepare the product to be ready to be produced at scale in the industrial pipeline. And we addressed these problems with a Giuseppe module called Chiara, after Giuseppe's mother. And finally, there is this flavor step in where we need to, I'm going to explain later why, but we need to supplement the products with flavors, because usually they are lost in the previous stage. And the flavoring part is also assisted by AI in a model called Vertumnus, after the name of the main picture I showed in the previous slide. So every technology, or at least every AI technology, needs to start by having good data. And how we have, or how we created our data, it's one of the main parts of our technology, because there's not so much data related across the food system, right? So in the early stage of the company, we had to come up with ideas of creating new data sources that look at the food from different perspectives. So we have like a scientific pipelines of equipment that extract different types of information for foods and for ingredients. So we have, for example, texturometry, infrared spectrum, GCMS, which stands for gas chromatography and mass spectrography, and the viscosimetry, among other machines, right? Everyone measuring different aspects of food. We also have data that come from the lab experiments that are carried out in-house. So, for example, we do colorimetry, pH, we measure pH, water activity, and we inspect fermentation processes, and a bunch of other stuff that every single experiment that is performed by a food scientist, it is documented in a structured way that goes back to our databases. And also, we have a team of AI chefs that are actually part of the AI team, and they are daily creating culinary data to train Giuseppe. For example, they cook Giuseppe's recipes, and they document back the sensorial feedback, the texture properties, the flavor properties. They document the ranking, they take pictures of the samples, they write down the recipe in natural language, and all that goes back into the Giuseppe's training database as well. After, besides all that, of course, we have data that comes from the web that we need to take advantage of, right? So there are hundreds of thousands of recipes on the web that we are using. There are nutritional food components available on the web. And there is also available scientific data, like data related to odors, flavors, volatile compounds, and all that. We scrap all that, and also it's inside our training databases. So I want to mention also that we envision the development of a technology for the food space as a collaboration between the AI and humans. We believe that both outperform either alone. Why the humans must be in the loop? Because first of all, Giuseppe was designed to assist the chef and the food scientist in their day-to-day tasks. Humans here have an amazing domain expertise that we need to use to train our AI and to solve the problems, right? And the food is still made for humans, which means that we need to understand the human perception, and it is subjective, so they always need to be in the loop. Probably what is tasty today, maybe it's not tasty tomorrow, and it changes across cultures and locations and so on. And also our data is created by humans. As you could see, all the lab experiments and the scientific machines are operated by food scientists. So they are creating the data because they believe that that data is useful to train an AI. So this is designed from the very beginning as a collaboration team, right? And also we rely on the human to evaluate the improvement of Giuseppe, right? No one but humans can tell us if the technology is getting better over time or not. And by the way, there's a very nice reading that is down the link there that was published by Google on how or why it's always useful to have the human in the loop when we develop AI technologies. Okay, so this is why here in every different stage of the pipeline, I show what are the different human teams that are collaborating with Giuseppe. So in the prototype phase, we have the team of chefs that interact with Viaggio to come up with the formula and the recipe of the prototype. Then in the middle, we have the food scientists that interact with Giuseppe's model called Chiara that solve together scalability and functionality properties. And later, we have the sensory experts that collaborate with Bertonus in order to come up with the flavoring that must be supplied to the current version of the product, right? So we have different models across these different stages of the pipeline. So I'll start with the prototyping part. So I have video demos. I believe that nothing better than video demos to show the technology. This technology, of course, is already deployed and working. So now I'm gonna show how is when a chef wants to create a plant-based formula to mimic a specific animal-based target, okay? So I hope the video is playing. So here you can click and search for a given target, for example, fish, then you can select any of those fishes available there. And then you can ask to exclude some of the ingredients, maybe some ingredients that could be allergenic. You can exclude soy, for example, if you want. Then you can tweak somehow the flavor profile if you want to have a degree of saltiness or required umaminess, for example. You can also restrict some nutritional features. Maybe you want it to have at least 30% of proteins or no more than 2 grams of fats, right? And then you just start generating the formulas. So that's the process that a chef follows to create a given formula. Now, I'll show sorry, the next slide here. What happens after the formula is ready, right? So the chef goes and search over the library of creating formulas, selects the formula we just created, and then we can filter because there are a bunch of selected plant-based formulas. And in the right, the black dots are the created formulas. We can filter by number of ingredients, by score, and then we can click on one of those formulas and look at the details on the ingredients and the proportions. We can keep exploring the formulas after the filter down in the page. And we can select, for example, to rank by novelty, which means like very novel ingredients that are being used in that formula. So then we can click to see even more details of the formula. And here we can see, for example, the flavor profile of the formula before even cooking it, right? It's like a prediction of the flavor profile. We can have the relationships of the ingredients and the macronutrients. Also, we can look at the nutrients and then we can filter them out and so on. So there's a bunch of stuff that the chefs can do. And finally, they even can bring the formula and take it to the kitchen later. So, okay. So then how the chefs provide feedback to Giuseppe. And this is the third part in where the chefs start typing. Let's say that the chefs cook the formula and then they proposed an improvement. So after they propose the improvement, they want to write down and document back the whole recipe with their improvements. So now they start writing again the ingredients they finally used. So we use these tags so they never make errors when they type their names. They put the amounts and they start writing down the preparation steps, like in plain text of the recipe. Those tags are again to make the reference to the specific ingredients in the formula up there. So they can document back the color. They can pick a specific color of the resulting sample. They can rank the how similar was the color with the target. They can put the smell, the flavor, texture, aftertaste. They can also describe the bitterness, saltiness, and all that. And they can say how similar to the target it was. And later they can load the picture of the given sample, right? So all that information is fed back into the training database. So this is one of the animations that chefs get when they provide Giuseppe with a new recipe. Okay, so now going to the models behind the formula generation. So finally, we could already have that. We have the first published patent related with the algorithm that generates the plant-based formulas. And I'm gonna explain this divided in two main steps. One is to learn a representation, which basically, today we can claim that we have an AI technology only if the AI is learning the representation of the information included in the data we are analyzing. In this case, ingredients and formulas, right? We don't want that humans do the feature engineering in order to come up with a presentation of the ingredients and formulas. We want the AI to figure it out, right? So the first stage is to learn a representation that later allows the AI to perform reasoning, right? And in the right side, we have like the formula search or targeted search, which is like performing reasoning or inference in order to find or generate the formulas that match a given animal-based target. So related to the representational part, we have like a deep neural network that learns how to embed different sources of different data sources. For example, that low-level data like macronutrients or chemical physical descriptors together with the web recipes, and they are very different nature data. So we have an architecture that we embed these different sources into the same space. And we call it here like ingredient representation. So at the end, as a result, we're gonna have like one numerical vector representing each potential ingredient. Later, we need to figure out a way to embed a formula, which is a set of ingredients, right? So after having the ingredient embedding, we have another neural network architecture that learns how to embed sets of ingredients such that each vector or each data point is going to correspond to a formula, okay? Which is a set of ingredients, right? So later, when we have learned this knowledge representation, we can grab any single data point in this embedded space and we can decode it into a valid plant-based formula, right? So that process, since that we can generate as many formulas as we want, and we can explore all the given formulas from this latent space, we need an algorithm that helps us to search or generate the desired formula according to a given target, right? So we have this processing where that this is the targeted search, and where we have an optimization loop that interacts with the chefs, because the chefs can input their own controls and restrictions during the formula search. And that is part of the optimization loop in where we are doing search over the latent space, providing generated samples of formulas to the chefs, and then going back again until we converge to an area of the latent space where the best formulas are generated according to that specific target, right? So after having all these potentially generated formulas, then we can select them under different criteria. Some of the criteria we have is like the similarity score, which is like basically a distance to the target in some space, but also a uniqueness, which tells us like, you know, this formula, it is unique because it's combining very rare ingredients. Like, for example, in the case of the NotMilk, in where we come up with a milk by combining pineapple and cabbage, right? So after having the formula, we need to know how to cook it, right? So Giuseppe also knows about creating the process or writing down the way to cook the ingredients that are present in the formula. And for that, the most natural thing is to use natural language processing, in where Giuseppe is trained to understand basically the language of recipes. Here I have a video demo. So here we can see that the chefs, for example, they want to know how to cook a given formula. So they start typing the formula. In other words, the sets of ingredients and the proportions. So they write down the ingredients there one by one. And after they finish with the formula, they press like a generate step in the right side, and then Giuseppe start generating the process. It is telling, like, you know, like put that amount of wheat flour, with that amount of cocoa powder and so on. So it's just like in natural language telling how to cook the given formula. So the chef keeps pressing the generate step until finally the Giuseppe tells like the process has finished. There is also this novelty bar in the bottom right part, in where we can ask Giuseppe to be more novel in the process. And this is challenging because in general, we learn, or Giuseppe learned to cook from the same human recipes. Now I'm not speaking about the ingredients, I'm speaking about just the steps. So if we want Giuseppe to generate more novel steps, what we do is like we increase the likelihood of like jumping out of the distribution of the predictions of the next step, such that we come up with some crazy cooking step, and might be we can discover later some innovative processes. So this is the way we are doing this. Today we rely on generative pre-trained transformer, or GPT-2. We are not using GPT-3 because it's still not free. So with that, we have like an initial understanding of English, right? Giuseppe understands English starting by adopting the GPT-2 architecture, right? And after we do the transfer learning into our in-house recipes. So we adapt this by, we manually tag these recipes, identifying all the ingredients in the recipe, in the training recipes, all the tools used for the cooking, and the actions applied to in every step, right? So when we train the algorithm here, we build a loss function that is penalizing every time we are not predicting an ingredient that's supposed to be there, or when we are predicting an ingredient that is not there. And we do the same with the actions. So we want that the actions predicted by Giuseppe correspond to the actions that belong to the ground truth recipe from where we are training. And we do the same with the tools, right? If there is a pan for frying, we want Giuseppe also to tell us that we should fry that sample with a pan as well. So all those aspects are part of the loss function that allows us to train Giuseppe into understanding how to cook the formula given the set of ingredients. Okay, so now moving to the second part, or the middle part. Now I'm going to describe basically the Giuseppe models that interact with the scientist to solve functionality and scalability problems. First, I wanna show here what we call Chiara Discovery, which is a dashboard. In this particular case, this is not an AI algorithm behind. In this case, we have a dashboard, that we believe that is an initial technology that every scientist must have in order to explore all the ingredients that are out there available. So I'm going to show a short demo here, in where the scientists can filter, right? Select ingredients by different categories, right? So then, for example, here they have these candidates. After the filter, they can select one in particular, and they can go and see the details. We can show them here, for example, the infrared spectrum of that ingredient in particular. We can see the nutritional facts. There's also information related with the amino acid profile. We can see the GCMS, and we can explore the spectrum in different wavelength ranges, and so on. We are still in progress of filling or populating this dashboard, this database. So that's the way to explore ingredients one by one. Also, let me see if we can do ingredient comparison, in where we can select more than one ingredient. Let me see if this is the right video. So again, you can do the filter, and for example, no, I think this is the same video, sorry. Okay. let's see. So here, after applying any other filters, right, this food scientist can select different ingredients. For example, lactose, right? That's one ingredient. And then they can clean those filters and apply a different ones. For example, according to the physicochemical properties or some sensorial properties like adhesiveness, they can do another filter, select other sets of ingredients like carrageenan and then or wire gum, and then they have 3 ingredients, and then they can compare them. Here, they compare, for example, they can see the FDR spectrum, they can compare them according to the physicochemical properties or nutritional facts. They can reorder the cards. They can look at the, again, at the spectrum to compare them to see how different they are, select the different aspects like lipids or different weight number ranges, and so on. So this is basically a dashboard to explore manually the available ingredients. And it's a very nice tool for food scientists when they are sitting and exploring all the potential ingredients that they can use to solve the food scalability issues, right? So I'm going to show some examples on this, like, for example, improve consistency of a given food matrix, or find accurate metrics in fermentation experiments, or maximize desired property like creaminess or crunchiness. All that could be done with this Giuseppe model called Toolbox, which is an experimental design technology. So here I have a demo for that. So the first thing that the food scientist must do is to define the experiment, because at the end, there are so many different experiments that for this tool to be useful, it has to be very flexible and allow any experiment definition, right? So here we have like a dumb experiment, which is basically how we can maximize the height of a cake, right? That's just a very basic thing, but is to see the use of this technology. So for example, you define the experiment with your name and you start defining the variables involved. One variable could be a categorical one, the flour type. And we can see that we have different flour types like coconut or rice or wheat. So after we define the flour type, we can add other parameters like the baking powder quantity. We define it as a float. We can define the ranges, minimum and maximum, right? So at the end, we define what we want to optimize. Our objective is the cake height, and also is the sponginess of the cake, right? So we define 2 different objectives to maximize with the same weight or importance. So after the food scientist define the experiments, and also you can tell the ranges in the objective function. So after the experiment is created, we can go and use the tool. Let me see, this is the next video. No, this is the same again, sorry. Okay, so here after the experiment is defined, the food scientist goes and find the experiment and start using it. So the first thing is we can see that here, Giuseppe is telling to the scientist what are the first 5 experiments that the food scientist must carry out. So here it's like telling basically, you know, I have no idea about this experiment. So I need initial, like a random initial data to sort of know the optimization function. So the system generates a batch of 5 initial experiments that the scientist must cook, right, in order to provide with the feedback data. So later, after the scientist finished cooking the experiments, he start reporting the information or the results. It is telling that after that variables of that amounts, those were the resulting height and sponginess. So after finishing, now is the next step in where the system suggests the next batch of experiments. So here the magic happens, right? Because in practice, when we go over and over, after 2 or 3 iterations, the scientist finds the desired values for the sponginess and height. So without this tool, the food scientists will be doing this trial and error and taking months in finding the right combination of ingredients to achieve a desired sensorial property. But with this tool, they can do the same in few days, right? So another tool I want to show is the protein search tool. And here, the main problem that we are solving is that in general, if the prototype tells you that you should use pea protein, for example, for a given formula, the food scientist has 50 different pea proteins, and all of them generate really different results in the final foods. So before, they were trying the 50 proteins and taking 4 months in finding the correct protein from the local provider. So, and if you do that in Chile and then in Brazil, then in the US, because everywhere you have different providers with different versions of the proteins, you're gonna take forever in launching the product in different locations, right? So here, we develop a protein tool that is also with approved patent that helps the scientists to search for the right or the best protein over a list of available proteins. And this is called the protein tool, and also relies in the infrared spectrum mostly. So here's the demo. Let's say that the food scientist selects the protein they are trying to reach. Let's say like for example, that is the desired protein, but it's not available from the local provider, and they need to select the best one or the most similar one from the list of available candidates. And also they can choose some of the properties of interest, like maximize the emulsion capabilities, and they can restrict certain categories as well. And they can use different methods like a spectra or secondary structure prediction, right? So they can see here that the system is ranking the proteins and also is showing what are the most similar or what are the clusters of proteins according to the secondary structure, which is like a proxy for the sensorial properties of the protein. So with this tool, they can go and try the different proteins according to the ranking, and again, take few days instead of months in discovering the right protein to use on each of the countries. Okay. Finally, we not so long ago, we entered into the flavoring part, which means like to design tools that interact with the sensorial experts to find the right flavors. So I know that it might sound confusing why we need flavors actually, if they're supposed to come from the ingredients. The problem is that in general, when you submit a formula into an industrial pipeline, the industrial machines start creating the product, but rapidly we lose all the flavor properties. They are gone. So we need to add them again, okay, at the end of the pipeline. So the flavor creation is an art, because this is related to human perception, to feelings, to emotions, right? And there are thousands of flavor compounds. So we believe that the AI can help us to discover new flavors and also to make them in a more sustainable way, because the animal is also involved in the flavor creation in most of the current flavor houses out there. So here we create the compounds and the foods tool, where the scientists can explore the volatile compounds present in different ingredients, such that they can understand what are the main compounds they should use to create a new flavor. So again, they can select, for example, the flavors they are trying to achieve. In this case, they are exploring what are the compounds present in the pineapple and cabbage, which are our main ingredients of the NotMilk. Just want to clarify that we didn't use this tool to come up with the NotMilk. This is basically a tool where now we are trying to confirm why these ingredients were selected by Giuseppe in the milk, and also to understand what are the volatile compounds that are present in these ingredients, right? So here, the food scientists also can filter by some flavor properties like creamy, for example, and then they can see all the ingredients that have some sort of degree of match in the volatile compounds with the ingredients selected up there, right? So then the scientists can explore each of the compounds and see the available information. So here we are combining different data sources that come in-house and on the web, and we are relating information like coming from the GCMS, the gas chromatography and mass spectrometry, and a database with volatile compounds, such that we can understand how to select the ingredients that can come up with the necessary volatiles that at the end result in a given flavor, for example, a chicken flavor or whatever. Oops, sorry, 100% again. So, okay, now I want to speak about the team. All this wouldn't be possible without this amazing team. I can tell that I have the best talents in the AI team. These are all the engineers in charge of all the tools, and they are the ones that created all the tools that we've seen so far. One of the interesting things at NotCo is that the AI team is very interdisciplinary. Like, as you can see, we are combining machine learning and data science engineers with software engineers, with designers, with chefs, and with scientists and food scientists inside the AI team. So in this case, for example, here we have scientists whose main goal is to train a technology. I believe that we are among the first companies in where we have a food scientist not taking care of improving products, but taking care of improving a technology. Well, our food science for AI team and the discovery biology teams are kind of new, like they have few months. So far we've been relying with our biggest partner in tech creation, which is the R&D team at NotCo. This team is taking care of all the things related to the product launching and the post-launching improvements, but also they are helping us in the creation of the technology. So this wonderful team of food scientists and product developers are every day giving us feedback and being part of brainstorming meetings in where they design together with us how all these tools should look like, what are the problems that they want to solve, and they try the tools and they give us feedback and tell us, you know, this thing doesn't work, or this thing is useless, or, you know, thanks to this tool now I took much less time into solving this specific problem. Okay, so I can tell that NotCo is an amazing company, mostly because of the interdisciplinary work and collaboration. This is why we can come up with such a disruptive technologies. So that's it. Thank you, and I'm happy to take questions now.
Thank you, Karim. Amazing. It's a data science machine learning playground to my mind. There's 2 questions on the Q&A already. I don't know if you can read them. I can read them for you, Karim. One is from Larissa. She's asking if you use AI in the preparation, or it's just the chefs decide how to prepare it?
No, the preparation is done by the chefs. I mean, we don't have Giuseppe like in hardware in the kitchen. It's in a software, it's on a screen. So it is telling you the recipe and the process, but the chef is the one actually performing the cooking, right?
And a question from Max is, have you observed any novel recipe generations that is actually culinary and sound, like that the chef would say, no way, I'm not doing that? I guess that's what, Max, is that what you wanted to ask?
Yeah, unfortunately, I cannot tell what, because it's related to things that we haven't launched yet. But actually, this is now one of our main focus. It's like how we can discover innovative processes, not just innovative ingredient combinations. But yes, this is one of the things we're pursuing, and we have some.
Stefania, she's asking, what was the longest time you spent developing a recipe?
I'm not the right person to answer that question, because the chefs are the ones that spend that time. But I would say that they usually, from my experience, they take around 2 hours in cooking the recipes, and on average, right? Because in general, they are complicated recipes, only involve plant-based ingredients. It's not the usual thing. So they take around 2 hours. on average. The longest maybe was 4 hours, no more than that. How long we took into creating a prototype? I think that's a good question for us, because sometimes we were amazed in how long we end up in that ready prototype. Like let's say we want to do tuna or a burger, how long we take into coming up with a solution, not scaled, but at least the prototype solved. That is an amazing thing we've done in some cases. I would say like sometimes we took 4 hours in having like a really, really close tuna fish or the burger, in a really final prototype of the NotBurger was ready in a few days, compared to other companies that are just centered in a burger and they took like years with hundreds of millions of price capital. We took few days with 4 people involved.
There's a question. Karim Jubi is asking, would you consider the final product as a processed food?
No, because after I knew what are the processes that are bought. In general, are chemical processes that alter the nature of the foods, and that is a processed food. But in our case, we don't do that. I mean, it's part of our restrictions. We use the natural ingredients and we combine them. We are not applying any chemical process that changes the nature of the ingredient. So our foods are not processed. If you always can compare with the house-made recipe. Of course, it's not going to be exactly the same thing because it's produced at scale in an industrial pipeline, but it's not as processed as the foods you see in general on the market, with a bunch of I forgot the name of these chemical preservants, for example.
Preservatives, yeah.
Yeah, preservatives, yeah.
Another question. What was the most surprising recipe by Richard?
There are several, but I always have in my memory the NotMilk one, because it was very special to me. We were under a lot of pressure from the board, like you guys should launch the NotMilk, what's going on, why it's not ready, and all that pressure was focused in our team, like why you're not coming up with the NotMilk, why it's not working. And I remember these times working a lot with the algorithm, running it, and one day I got a call from the chef and she told me, you know, you're not gonna believe how is the new formula of the NotMilk and what are the ingredients there. So when she told me that it was pineapple and cabbage and I tried it, I was like really almost crying of happiness after getting that result. So I'll always keep that formula in my heart.
Okay, let's see. Faraz has actually asked the question on the chat. Are there any plans for open source version of the dashboard?
That's a good question. Well, we are heavily now trying to do partnerships with other companies. And we are thinking in open source some of them, as far as we don't feel that we can get direct competitors. So this is something we have to figure out with the rest of the company. But the next step is to impact the industry by putting our technology available for the rest of the world, right? I don't know if it's going to be for free, or I don't know the economical model we're going to have for the technology, but we are really pushing for making the others change the way they do food. This is what we want, right? We want to change and reserve the whole world, and we need to use our technology for others as well. So not sure if it's going to be totally open source, but it could be.
Here's one I like. Have you competed your software against top chefs?
Well, our chefs are top. I mean, we brought the best chefs. I mean, you won't believe. I mean, when I go there and they do the lunch for us, I'm the happiest person in the world. They are extremely good. And several times I saw their faces on how impressed they were from some recipes. So I believe that any human chef, no matter how good they are, they come with a bias in the way that they were taught in the university on how they should cook the recipes. So when they get a technology that is suggesting to combine crazy things, they are impressed. And I don't know if it's a way for them to compete directly because they are different things, but I believe that they work great as a team. but we have the best of the best chefs of the country, and are now at NotCo. I can guarantee that.
So one is, what types of ML models did your team try? Or was an embedding model an obvious way to go?
Well, I show that, right? And it's basically on a first stage in where a deep neural architecture learns the representation through an embedding on different data sources. And then within that embedded space, we perform the optimization to do the search according to the human controls and stuff. So that's the algorithm for the formula generation. And you saw like the NLP for process generation, Bayesian optimization for experimental design.
Everything that we teach is in that.
Yeah.
And there's another good one. Have you observed any difference between the preference in taste between Chile and the US?
Yes, that's a very important question. And this is why we need to adapt every product according to the country. If you try the NotMilk in different countries, it's not the same. And it's because of that. Today, this adaptation is done by humans. We are not at the level that the technology is helping up into adapting the formulas per country, because we don't have enough data in other countries. So these changes are done by the sensorial team on every country.
So have your sales of NotMilk in the US met expectations? I've been buying it, by the way, Karim.
Yeah, I'm not in the financial team, and I'm not good for sales for the numbers. I don't have the numbers in my head, but I just know that they are doing well, very well.
Okay, that's good enough, I guess. Have you considered, Giuseppe, like an app for general use for everyone? I think that goes back to the open source. I mean, can I use it to create my own recipes? I think that's...
Yeah. Not today, but no one knows what's going to happen in the future.
So there's one about the animal protein, Javier, is how do you achieve the right functionality of animal proteins alternatives, since they're extremely complex and interact in several ways, water holding, emulsion, etc.?
Yes. Yeah, that's a good question.
I had that question too.
And actually, that is the main reason why we have all these scalability and functionality issues in the middle of the pipeline, right? Because all that is because of the differences between the animal-based proteins and the plant-based proteins. So depending on what you want to solve, you need to address that problem in different ways. So in some cases, if you want to improve the consistency of a given mayo, for example, that problem is because we are using plant-based protein. And we address that by doing a different combination of oils and starches and other stuff to achieve the right consistency. And we do it with this toolbox, right? But then later we realize that we want to solve a fermentation, because when you are doing fermentation with plant-based protein, it's not the same when you are doing fermentation with of cow milk, right, or for yogurt. Again, you're going to have creaminess problems that come out of that difference again, and you need to solve it with another experiment and so on. So far, we divide and conquer. We divide the problems and we solve them separately.
Hello?
Hey, Max.
Okay, hi. Thanks so much for this talk, Karim. I'm curious, is your process mainly an algorithm for finding recipes, or does it also somehow like evaluate the quality of recipes?
That's a good question. Like, well, first we find them, but we generate them, right? I mean, the things like in general, if you want to mimic an animal-based target, you don't know what to do. You don't know what to combine to reach the formula that it is really close to the animal version. So the first thing is like to come up with that formula, but later, in the moment when the chef documents back the sensorial feedback, we can have an understanding on how close it was. We have a whole evaluation platform that I didn't show that is used every time we come up with a new version of the algorithm. We need to make sure that it's actually better and that it's improving, and also a way to evaluate how much we are improving as we increase the training data. So this platform has several tests that run and compare the results of the formula for different algorithms. Also, that testing platform includes the humans. So there are automatic tests that are carried out, but also there are some human testing where the chefs again need to go and cook formulas coming from different algorithms or different amounts of training data, and they need to document back and compare such that later we can decide if there is an improvement or not. So we are taking care of the evaluation.
Thanks very much.
On your project, did you use or are you using any open source library? And are you worried that in the future that library could be updated or maybe closed for any reason?
We are using open source things, but they are really, really open. I mean, I don't think it is the typical basic library. It's probably the most advanced library we are using that is open source is GPT-2. But the rest are the usual things like libraries for coding that are available that I don't see. I mean, if any of those libraries were closed in the future, the world will stop, right? And it is being used for everyone, everywhere.
Perfect.
We use Python, and we use the usual libraries and PyTorch for deep learning.
Perfect. Thank you.
Thank you, Karim, again. Wonderful talk, wonderful company.
Thank you. Thanks for the invitation again. Bye, everyone.